Hello everyone, this is Pratyaksha ma'am, and today let us study an 8085 program to add and subtract two 8-bit numbers. Now the program is to add and subtract two 8-bit numbers which are stored in the memory locations 0015 and 0016. And we have to store the result, that is addition result we have to store in 0017 memory address and subtraction result to be stored in 0018 memory address. So first let us understand the logic of the program. See, the memory locations are already specified to us, that is 0015 and 0016. So let us assume two 8-bit numbers. First let us take for 0015H and we'll assume some data. Say for example it is 4H, the data for the memory location 0015, and for 0016H let us take another data 02H. Okay, so this is the input we have to give, and what will be the output, and where should we get the output? Addition result according to the program we have to store it in 0017 and the subtraction result has to be stored in 0018H. So this is your input, and what is the output? Addition result should be stored in 0017H. Okay, so we'll just assume this 4 and 2 now. So when we add, let us take it as 06, and then the subtraction result of the same two numbers we will get it in the memory location 0018H. So this is the logic of the program, that is take two numbers, 8-bit numbers, and first load them in these two memory locations 15 and 16, and then store the addition result in 0017 and the subtraction result in 0018H. Okay, now let us write the code for it. So first of all we need to load the first number. So for that we can take the instruction LDA, and the memory address is already specified to us, so we cannot change that, and it will be 0015H. Now what happens here is the first number we have to load it in this memory location 0015, and if we assume it to be 4 now, so when we use this instruction LDA, what it does is the operation of LDA is address to accumulator. That means whatever data is present in 0015, this memory location, it is going to transfer it in the accumulator. So that is 0015H data will be transferred to the accumulator. So after execution of this instruction, we will have accumulator will have the data 04H. So accumulator will have 04 in it. Now that means we have loaded the first number in the accumulator. Now similarly we have to load the second number, that is 02, in the memory location 0016. So to do that, now we can make use of LXI H, 0016. Okay, now here you should remember that again we cannot repeat the instruction LDA and take the memory address 0016 because the first number is already present in the accumulator. If we use LDA instruction here, what will happen is the previous number, the first number what is there in the accumulator, it will be deleted and the new number, that is your second number, will be placed here. So to avoid that, we are, instead of LDA, we can make use of LXI instruction. So LXI H, 0016. Why 16? Because that is the memory address given to us in the question. So here this 0016, now this memory address okay, will have the second number, that is 0 to the data which we have taken, and HL acts as a memory pointer. So right now we have HL acting as the memory pointer here. So that means in the memory address, that is 0016, we have the second number, that is 02, which we have assumed, right? So now we have loaded the first number which is present in the accumulator. The second number is present in the memory address, okay, 0016, and we have to, now we have got both the data present here, so we need to add them first. Okay, so which instruction will help me to perform addition now? Remember, the first number is in accumulator and the second number is in the is in M. Okay, so it's better to take ADD M instruction. So why this? I have already told you that. See, the first number is in A and the second number is in M. So when we add this, and the result is stored back into the accumulator. So the operation of add M is A plus M, and the result is stored back into the accumulator. So if you have 4 in the accumulator and 2 in the memory address, and the result is 6, which will be stored in the accumulator. So till here now we have performed the addition part. Okay, the first part, that is addition, is over. But you should remember that as per the question, as you can see here, the addition result needs to be stored in the memory location 0017H. So we cannot keep it in the accumulator. So that is why what we have to do is we need some instruction which will bring the content from this accumulator and store it in the memory location 0017. So we have already STA instruction, as we know, and we can take the memory address 0017H. So what this instruction is going to do now, whatever contents are there in the accumulator, that is 6, will be stored in this memory location 0017H. Okay, so 0017H will have 6 in it. And what is this? This is the addition result. So your first part is over. That means we have performed this addition part now. So this partial output we have got now. So the next part we have to continue with subtraction now. So what we do is, the first number, as you can see, which was loaded in the accumulator, that is 4. Okay, what has happened to this number? Now when we performed addition here, we made use of the accumulator here, correct? So that is why there will be changes made here to the accumulator. So what we do is, once again we will have to make use of LDA 0015H. So here what we have is, again from 0015, that is the first number 4, will be loaded back into the accumulator. Okay, now why this is done? Because when we performed addition, the result was stored in the accumulator. Now after this, the second part, LDA 0015H. Okay, we have already loaded the number. Second number, there is we don't need to load it again because it is already present here in M. So simply we have to just make use of SUB M. So it has to be M only here, because our number is, the second number is loaded in 0016H. Okay, so now it performs A minus M, and the result is stored back into the accumulator. So it will perform 4 minus 2, and the result is stored back into the accumulator. So you are going to have A as 2. So when I perform this subtraction instruction SUBM, my result of the subtraction of two 8-bit numbers, it is already now stored in the accumulator. But as per the question, you know that you have to store the result in the memory location 0018. So again we will have to use STA 0018H. So what it is going to do is bring the contents from the accumulator and store it in 0018H. So that means what is there in accumulator? The result of the subtraction is present in the accumulator. So that is transferred to this memory location. Okay, you can make it as 02 here, and that is brought into this memory location 0018H. So that means we have performed the second part also now. That is, you can see here in the next location we have, that is 0018, the subtraction result is stored. So we have got both the outputs here. For the first part was of addition and the second part of subtraction successfully. Okay, so we have to terminate our program. So for termination we need to use the instruction HLT. So HLT helps to terminate the program. So that's how we have performed today a program on how to add and subtract two 8-bit numbers. If you have any doubts, you can ask in the doubt clearing session. Thank you.